Let's look at some examples of compounds and see if we can figure them out to be aromatic, anti-aromatic, or non-aromatic. Alright, let's look at the conditions for aromaticity and anti-aromaticity again. To be aromatic, the following conditions must be met. The system must be cyclic. All double bonds and or charges must be conjugated, that is, they must be alternating with single bond usually. The system must be flat or planar, and there must be 4n plus 2 pi electrons in the system. To be anti-aromatic, it's the same conditions, except there must be 4n pi electrons in the system. And remember, everything else is considered to be non-aromatic. Alright, let's look at the first one here. The first one is benzene, and it has 2, 4, 6, that's 6 pi electrons. We're assuming everything is flat, so that won't be a complication with any of these. We're just going to straight out assume they're flat. So that condition will automatically be satisfied for every single one of these compounds. We have a cyclic system, and we have alternating double bonds. Double, single, double, single, double. We also have 6 pi electrons. 6 pi electrons falls into the 4n plus 2 category. So this one is going to be considered to be aromatic. So A equals aromatic. This one is cyclic. It's got alternating double bonds, so that's okay. It's flat, and it has 2, 4, that's 4 pi electrons. Now this fits the 4n electrons, where n is 1, so this one is going to be anti-aromatic. This one's got 2, 4, 6, 8 pi electrons. So that again fits the 4n, where n equals 2. And that means that this one will be anti-aromatic. It's flat, and it's got alternating double bonds as well. Double, single, double, single, double, single, double. All the way around, so that's going to be anti-aromatic as well. Alright, this one, it's cyclic, but it doesn't have conjugated double bonds, because it goes double, single, double, but then it goes single, single, single. In order to be conjugated, it has to be conjugated all the way around the ring. And in order to make it conjugated, we have to put another double bond in here. So this one is going to be considered to be non-aromatic. Right, this one is not even cyclic. So that's out of already. So that's non-aromatic as well. Right, this is naphthalene, the main component of mothballs. 2, 4, 6, 8, 10. That's 10 pi electrons. And 10 pi electrons fits the 4n plus 2, where n equals 2. So this is going to be considered to be aromatic. Again, it's flat, and it's got alternating double bonds. Double, single, double, single, double, single, double, single, double, single, all the way around. So that's aromatic. This one, we've got alternating double bonds. It's flat, it's cyclic. We've got 2, 4, 6, 8. That's 8 pi electrons. And that fits into the 4n category, where n equals 2. And this would be anti-aromatic. Now we're moving into some other examples where other things other than double bonds are conjugated with the pi system. Now it doesn't have to be a double bond that's conjugated. We can also make it a lone pair of electrons, or we could make it a charge. And we'll look at some of those examples as we go. Right, this one's called Pyrrole, and we have a cyclic system, and it is actually also conjugated. We've got double, single, lone pair, single. And this lone pair is actually going to be part of the pi system. 2, 4, 6. And that actually has 6 pi electrons. That means it matches 4n plus 2, where n equals 2. So this one is going to be aromatic. Right, in this case, this is called furan, and this is cyclic, and it's got alternating a conjugated system. We've got double, single, one of these lone pairs, and single. So not both lone pairs can be part of the would be part of the aromatic system. Just one of these lone pairs would be, and that would give us 6 pi electrons, and that would again be 4n plus 2, where n equals 2, so this would be considered to be aromatic as well. This one is cyclic. It's got a conjugated system: double, single, charge, single, double. So it's all conjugated all the way around. It has 2, 4. That's 4 pi electrons. An absence of electrons here because it's got a positive charge. So there's no electrons on there. But it's still, that positive charge is still conjugated with the system. What it actually is an empty p orbital, but it can still be conjugated with this pi system. And that's going to be 4 pi electrons, 2, 4, which fits 4n. So this compound would actually be anti-aromatic. This one has a negative charge, where this one had a positive charge. A negative charge means it's got actually an extra electron, and there's 2 electrons on that carbon due to the negative charge. Now this is actually a conjugated system. It's cyclic as well, of course, so we've got double, single, single, charge, single, double, single. So everything's conjugated all the way around, and because we've got the 2 electrons here due to the negative charge, we're actually going to have 6 pi electrons. And that's going to be 4n plus 2, where n equals 2, so that's going to be aromatic. Now we've got this system where we've got 2, 4, 6, 8, everything's conjugated, and we've got a 2 negative charge on the whole thing, and that's actually going to be part of an aromatic system where we've got 10 pi electrons. So 2, 4, 6, 8 due to the ones in the double bond, and then extra 2 negative, 2 electrons extra from the outside. And this is going to fit 4n plus 2, where n equals 2. 4 times 2 plus 2 is 10, and that means that this system would actually be aromatic. Without the 2 negative charge though, it's anti-aromatic. And this one that has the charge on it, it's cyclic, but it's not conjugated because it goes charge, single, double, but then it goes single, single. So that's not conjugated, and we would just consider this one to be non-aromatic. It's worth saying that most compounds in the world come out to be non-aromatic. It's just the special cases that actually turn out to be aromatic, and the anti-aromatics tend not to exist in nature because that requires that they actually be flat, and while these compounds might exist, they just don't exist in a flat form.